Good morning. 감사합니다. Thank you very much for having me here. My name is Johnny Poon from MKS Atotek. I'm the general manager responsible for DWE, Deco, POP, WRC, and Energy. Today we are going to share with you some update about our sustainability solution, including our Covertron process, which is a chrome-free etch POP application. Also, we will talk about our TriChrome and also BluCr application for functional chrome, and also non-PFAS applications. Let me start from the legislation update. This is the update of the EU, European Union. And you can see here the main message here is that Chromium 6 is falling into another category called Annex 17. And there will be discussion about the ban or the restriction of the use of chromium trioxide next year, 2025. The message is that the ban schedule is not fixed yet, but we can expect that the law will be implemented in coming years. So it means that in Europe, the chromium trioxide will not be allowed to use anymore. So what will be the impact to us? I think for plating industry, the main application of chromium trioxide is mainly falling into these areas. First of all, you can see BluCr, which is the functional chrome application, which use a lot of chromium trioxide. The other one is the Deco POP area, which is consisting of two areas. First is the chromium plating. The other one is the pretreatment of plastic substrate. First, let me start with the Chrome 6 free etch for POP application. So I think a very short introduction. I think everyone knows that in plastic substrate, we are using chromium trioxide as an etching solution. And it is to etch the plastic surface and metallize the parts. And we are using chromium 6 and also PFAS film suppressant in this application. And you can see after the pretreatment, we are going through normal process like copper nickel chrome. And our solution is Covertron 600 as a replacement of chromium 6. You can see here it is the SEM picture of a comparison of Chrome 6 etch and Chrome 6 free etch from our process called Covertron. And you can see on the left-hand side, it is a Chromium 6 SEM picture after etching. On the right-hand side is the Covertron with different substrate like ABS, ABS-PC. You can see the etching pattern is not identical, but I would say very similar. So we can expect that the appearance and also adhesion is very similar with the Covertron 600 process. And it is Chrome 6 free and non-PFAS process. You can see this as the process sequence of Covertron 600. It consists of a normal etching process like the Chromium 6, and then reducer, activator, accelerator, normal electrosnickel process. All these things is really almost identical for a normal POP line in the market. And then after that, we go through a normal process like copper nickel chrome. On the left-hand side, now you can see the real process sequence of Covertron 600 compared to the normal traditional process. I would say it is a one-to-one replacement. So theoretically, you can put in Covertron as a one-to-one replacement for your line. So you don't need extra tanks. And the only thing you need to be aware is that you need to have a red conditioner process additionally. But other than that, nothing changed. And even the etching step, you can see the etching temperature is only 35 degrees Celsius. And you can think about the energy consumption will be a lot lower than the normal Chrome 6 etching process. And on the right-hand side, you can see we have a so-called Covertron 600 CRU, or we call it regeneration unit. This is to really regenerate the active component in the etching solution, which is consumed during the etching process. So we need this CRU as maintenance tools to recycle the raw material in the etching tank, so that it reduces the cost, and also it helps to maintain a stable production. And the first question that you will ask about the performance is about adhesion. So we did a lot of tests on adhesion, like different thermal cycle or thermal shock test according to different OEM specifications, like Toyota TCT, Volkswagen PV1200, all this different cyclic corrosion test. We passed that without delamination, without cracks, without blistering. All these things you can see in our slides here, and it's proven that the adhesion is almost exactly the same, as good as the Chrome 6 application. This is about the compatibility to different plastic substrates, because many of our customers are using different substrates in their production, like ABS, ABS-PC, or even 2K, 3K materials. We have been testing that for almost a few years from now, and we've created a database of different substrate. I cannot say that every substrate we can do with Covertron 600, but I think the compatibility is quite good, and we can use the same process for different substrates. So it means that for ABS, ABS-PC, we need only one process. And I think that's very important for automotive application, because most of the substrate that we are using today is ABS or ABS-PC with different content, with different PC content. So this process, Covertron 600, is able to plate different substrate with one process. And also we have pilot line in Germany, in China, that will be able to help you really test your substrate to prove that the substrate is working with our process. This is a production process which is working in many of our customers already. In the past few years, we have installed more than 20 customers with Covertron 600. A few of them are in real production, not testing phase, but real production. That means every day 100, 150 fibers. So with different substrate for different applications, including automotive and non-automotive applications. So with this process, we can plate ABS, ABS-PC, 2K, 3K parts, automotive, non-automotive application. So it's a proven process that is working in production. Yeah, I think I will skip this page. I think it's a summary, short summary about our Covertron process. Then I will jump to the TriChrome process. For our trivalent chrome process, you can see we have a series of different colors. I think compared to Chromium 6, I think the color is quite limited. We of course have a Chrome 6 black process, but for TriChrome process, we have different colors. You can see on the left-hand side, we have two different processes for white color. One is a TriChrome Plus, which is a chloride-based process, and there's a TriChrome Ice, which is a more bluish process, sulfate-based process with good flowing power. And on the right-hand side, you can see we have different series of dark trivalent finishes, which is, I think, nowadays very attractive to the market. Many OEMs, designers, when we talk to the OEMs and their designers, they like all these different finishes. And that's very important for us because nowadays all the consumers, they would like to have new fashion colors. So we have starting from smoke to shadow, titan, graphite, phantom. I'm not going into details, but we have different series of color, and we are still developing new finishes for TriChrome. As said before, for bright finishes, we have two options. One is TriChrome Ice. The other one is called TriChrome Plus. And you can see both of them could pass all the functional tests like cast tests, NSS tests, calcium chloride tests. All the functional tests they can pass. The difference is TriChrome Plus is a chloride-based process with very good efficiency, very high plating speed. And also, we have a lot of experience with this process. But of course, the disadvantage of TriChrome Plus is that when compared to a normal Chrome 6 finish, the color is a little bit more dull or black compared to the Chrome 6 finish. So we have another process called TriChrome Ice, which when you really need to match the color of Chromium 6, you hardly can distinguish between TriChrome Ice and a traditional Chrome 6 process. But the drawback is that the speed is comparatively slow compared to TriChrome Plus. So it's your option, and also OEM have different opinions on this. So we have both options for use to choose. But according to different OEM specification, then we can use different processes. Come to dark finishes. Nowadays, it's becoming very popular. And I think especially in Korea, I see a lot of cars with dark finishes. And we have a series of different color for your choice. We have Phantom, Graphite, also Titan. And then even we are developing new finishes according to the OEM requirements. And you can see here, we can pass all the functional tests like CARS, NSS again. And for the automotive or OEM approval, please contact us if you need. We have a list of approval which is qualified by the OEM, and you can see all this color according to OEM specifications. And to give a stable process, we need a post-treatment process for all our TriChrome applications. So we have two processes. One is called TriSeal 300, the other called TriSeal 500. TriSeal 300 is specially designed for the bright TriChrome finish, and the 500 is mainly for the dark finishes. And with that, post-treatment, you can pass all the NSS test requirement, and then with a stable color in the lifetime of your parts. And it's not only TriChrome. I think TriChrome is just the top finishes, but I think for the industry, all we need to understand is that all the performance, especially the functional department, performance like NSS, CARS, they are all interrelated to the nickel process, even copper process underneath. So we have a lot of experience. We need to fine-tune the nickel processes to make sure that the performance is up to the standard. So please don't hesitate to contact us if you have any question about how to manage the nickel process, and we are happy to support you. And we have a lot of experience for TriChrome. We have over 40 years experience in the company. And we have a lot of experts also in Korea, in different regions, who are happy to support you. So after that, I will walk you through the functional Chrome part. And we have a process called BluCr in our portfolio, which is substitute to the functional hexavalent Chrome. quickly walk you through, I think compared to Deco POP application, functional Chrome is a bit more difficult because we have different chemistry component with complexing agent with different requirement, and we see it's a bit more complex. Therefore, you can see in our process, it's not a one-to-one replacement. For functional Chrome, we need a nickel underleaf layer in before the TriChrome plating. So you can see to really ensure that the process is working well, comparable to the Chrome 6 application, we need a electropolish step, and also we need a nickel stride and nickel plating process afterwards. And with that, when compared to the plating speed of a traditional or conventional Chrome 6 process, you can see the BluCr with the blue dotted line here. The plating speed is comparable to a normal Heath process, which is a conventional Chrome 6 process. Functional Chrome, of course, hardness is very important. When we compare the hardness of our BluCr process to the hexavalent Chrome process, the as-plated hardness is not as high as the traditional one. But you can see on the right-hand side, after heat treatment, the hardness is comparable to normal Chromium 6 process. I think I will skip this one. This is also the hardness with different comparisons. You can see here is the abrasion test. And again, very comparable figure to Heath and also conventional process. Again, coefficient of friction, also similar. For corrosion protection with the nickel underneath layer, of course, the BluCr process is comparable or even better than the traditional Chrome 6 process. About calcium chloride test, I think especially for some special application, we need to pass a calcium chloride test. And this time, BluCr is even better when compared to the traditional hex Chrome process. And you can see the first change is visible only after 96 to 120 hours. And you can see we already have some application and really industrial example that is using our BluCr for testing. And you can see for mining application, because of the better corrosion performance, you can see the test here is that they use the different processes, and BluCr with nickel really shows better corrosion in real industrial application. You can see we are plating different parts for with BluCr, and with different geometry, different application, it all works. And I think that the challenge for different geometry in functional Chrome is there, and we see there's a great variety of parts to be plated, and we did a lot of sample platings already, which proved that the process is working for different substrate, different geometry, and that's the BluCr process, which is compatible with most of the substrates. Different applications. We are using this BluCr in different parts, like hydraulic parts. I think we already have some customers really in production. Also, we have different standard automotive parts like brake pistons, piston wing, engine valve. Those are all the application for the BluCr chemistry. And then we have different application like general wear and corrosion requirement is needed. And especially, I think we emphasize the high chloride containing environment, which is very, when compared to the traditional hex Chrome, is outperforming. This is an example of application which is an engine valve. And normally it's a high current density application for Chrome 6 plating. And we are able to kind of outperform Chrome 6 with the BluCr. I'm not going into details because of time, but I think we can use the Q&A section, or later we can discuss in details if needed. As a summary, BluCr is again a production-proven process, which is available in the market as a replacement of Chromium 6 application, and it's stable. It can offer really similar performance compared to the hard Chrome application, and it can offer even better corrosion resistance in some special application. So this is a replacement already in the market for you, and I think that's the summary. Non-PFAS application. So the next topic is about non-PFAS application. PFAS is used in a traditional Chrome 6 process for functional Chrome, for deco POP. So it is a kind of forever chemical which will not decompose in the environment, and it's proven to be dangerous, toxic to human beings. So there's regulation coming in different regions to ban this substance, and we have different alternative for you, like WA POP etching for plastic, and also we have wetting agent 100 for decorative hexavalent chrome applications. Okay, this is a two-component system which consists of two chemicals. One of them is to form the foam blanket, and the other one is the height controller. So you can use these two products to really form, on the right hand side you can see in the picture, a very uniform dense foam layer on top of the hexavalent chrome process. Because of the time, now let me go straight to the point. I think the next topic is really the CO2 emission or CO2 footprint for our industry. So we did some analysis, and I want to show you the data. But I think how important CO2 is to our market, to the OEM, I think I don't need to repeat that. I think this is very important to show. We did an analysis to compare. On the left-hand side, you can see the chart. On left-hand side, you can see electroplating, and then paint, 3-layer paint, and also PVD. So I think this is the 3 major processes that the industry is using nowadays. And when we compare this electroplating, I mean Covertron and TriChrome, to a 3-layer paint and PVD, it shows even a lower CO2 emission compared to paint and PVD. So I think the impression that electroplating is not so environmental friendly, or is creating a lot of CO2, I think we need to change that. And with our analysis, of course, there's a lot of limitation, like what kind of energy are you using, what kind of metal are you using. Those are the main drivers for the CO2 emission. But we see that even with the benchmark that we set, we see that electroplating is not as generating as much as CO2 compared to paint and PVD. I want to summarize today's presentation with the followings. First, I think the many of our customers, many OEMs may think that the regulation is coming, but it's not there yet. It will take a few years from now to really comes to the restriction or ban of all this dangerous substance. And people are thinking, it takes a few years, we still have some time. But our experience in the industry is that it takes time for the supply chain, especially for automotive to really adopt a new technology. It takes a few years. So all I can say is that really the solution is there. We can offer all the solution to the market with production proven process. If the OEM or your customers have this request, come to us, and we are happy and more than happy to support you with that. But the conclusion is that we need to react, and we need to react fast.
Good morning from my side. My name is Sabine Sengel, and together with Mr. Choi, who is so kind to translate for me, we would like to share another chapter in our world of environmental friendly development for CO2 savings. And in this session, we will now talk on what is possible in regards of CO2 savings when you are talking on electrolytic finishes, or then also have a glimpse on zinc flake finishes. Let's have a short introduction. What is carbon footprint? And I think we heard a lot this morning already. Thank you to Dr. Shin, who explained us a lot what is coming up in the European Union. And of course, this all is driving our considerations. We need to shift to CO2 saving processes, and this is what we are going to explain in the next minutes. And of course, when we are talking on these carbon footprints, they are usually reported in like tons or tons of emission, but of course then for like coated surface or energy consumed during the production. The OEMs already, we are all here talking on solutions for the automotive supply chain. The OEMs are talking already, they want to be CO2 neutral end of this decade, like end of 2030, 2029, 2030, and the next decade, 2039. So this sounds a long way, but as we know, and Johnny also told that before, when there is a new process introduced, that needs really time until that is implemented fully, and therefore this sounds far away, 2030, or like Mercedes 2039, but for new processes, that is tomorrow. We need all to work together making that happen. Let us have a look. Where are the starting points for CO2 reduction and corrosion protection when we are looking in plating or coating processes? What can we do to save CO2? And we can reduce process steps. That could help if we are faster and the process is shorter. We could have, and I will show you in a minute, auxiliary equipment, how we call it, that these are tools to extend the lifetime of products, to be more efficient, to increase productivity, or to enable longer lifetime. And of course, we are a chemical company. We can design the chemistry, that there is special, that there are special possibilities to use lower temperatures, or to use electrolytes who can resist higher temperatures, or that there are baths which have a really long lifetime. This all can pay into CO2 savings. Let us have a look in the zinc-nickel electrolytes. What is really possible when we are talking on a theoretical barrel process, a bulk production in a barrel line. And if you are seeing on the right side, there are many influencing factors which are used in that in a typical barrel line, from where the energy is going in, where mainly also the CO2 emission is coming from, like from barrel rotation, from pumps, from hydrogen de-embrittlement. These all are things where it's not so easy to influence them. At least it is sometimes also connected to a lot of invest. So let us have a look to the other side, to the blue marked areas here, and let's think about what can we do on rectifiers, because they are somehow related to the efficiency of the bath, and what can we do related to heating and the coating. So these are the topics which we would like to have a look in the next minutes. We know, of course, a lot of lines, and we know where are pain points in lines, and we have developed pain points in regards of CO2 emission, of course, in that case. We have developed with our specialists kind of CO2 calculator. That is a just simple Excel-based tool, but there is a lot of specific information and experience in. So with that, we can really do a full process simulation, and this process simulation is then customized to each line which we are analyzing, which can help really to find for this specific application where are the levelers for the CO2. So at the end, with this can be a simulation done, and of course we can also think about what to change. On the other hand, we can also do a detailed product carbon footprint as defined in the ISO, in that case 14067. And of course there, then you have also, you can also achieve data which can be shared later on an official outcome also in regards of government, but that is something what is of course much more expensive and maybe a little bit more forward-looking. The Excel is already the easy solution, but you need to work really together with our team, because we need also a lot of data from your line, so that's not something what's done in a fingerslip. When we are talking on saving, I just want to give you an impression how much can be influenced just when we are talking on the electrolyte. We have in our zinc nickel portfolio, in our zinc nickel processes, a lot of different kinds of application. And as I said before, there is also the opportunity to use auxiliary equipment. And if you are looking to the black dots here, you see there are processes where you can really have a lot of savings. And we are talking here of CO2 savings just by choosing the right electrolyte and the right setup of the anode system, where what you can save between 10 to 20, 30, or even up to 45%. And of course, we would like to explain you a little bit how could that look like, and how you could take profit out of that. And the first what we are looking here will be a zinc nickel process, which is already production proven, of course, but it's still new. It's a zinc nickel 450, some of you may know, and we have developed the new additive concepts. And with these new additives, you will not see these aging. So this electrolyte stays much longer on I would say less aging on a new level as a new electrolyte. And you see even in this simple comparison, after 100 ampere hours per liter, this is even looking much better than the other original electrolytes available in the market after half of the time. So working here on the concept of the additives helped a lot, and you will see also what additional advantages that will have. With this electrolyte and with this new carrier system, you can even plate parts with very dense holes, and of course these are barrel parts, also possible with very much filled barrels. I know these parts are done in a really huge barrel application, and they are really very homogeneous plated. And despite that, this very good throwing power, also you can have a very good plating speed. So for this can be very interesting, because you can already have, just by choosing the right electrolyte, a lot of advantages, and you will pay in for CO2 saving of around 10 to 20% just with the change of the electrolyte. We have seen a solution which is fast and efficient, and let's have now a look in a solution what can be even more or less wastewater free. Harald Arnert already gave a small glimpse this morning. We are talking here on our CMA closed loop, which is really a winning technology for all of you. Could be very interesting. This is really, like we say, closed loop. So the system is self-contained and it is working really in recycling also the nickel waste and the wastewater at all. So it is also an opportunity when we have limitations in availability of water on your side. And you can imagine in some areas where we have really dry environment, that is absolutely interesting. The CO2 saving in this, with this solution, when we are recycling the water, can be up to 45%. So this is in regards of CO2 saving and the tough requirements which are coming up in all over the world, and in the beginning now mainly European Union is driving that. Of course, it is a important point, 45%. Have a look what is CMA closed loop. CMA stands for compact membrane anodes. So we are using here anodes which are separated from the electrolyte. So we are using their separation by membranes. These membranes you see here on this picture, they are replacing all the nickel anodes in the installation. You see here the normal barrel process, and in the beginning, of course, the rinsing. Then we have the alkaline zinc, and as I said, alkaline zinc nickel, as I said, and then we have the rinses afterwards. We need some tools to work in a closed loop, really in a cycle. So what are we using? We need to have an evaporator. So after the zinc nickel plating, the wastewater is going into an evaporator, separating the water and the zinc nickel solution, and bringing the zinc nickel solution back into the alkaline zinc nickel, and bringing the water, what is condensed, back into the rinse. So we are really, this can be done in a closed loop. We have customers running that since years, and really we will see it later saving a lot. Of course, you need to take care on the carbonate sludge. We need a freezing unit also in that line to get rid of this. But at the end, together with the special additives, that is really a system where you can forget about your wastewater sorrows if you have issues with that. If you see this example in a customer experience, you see here after 3 years or 4 years when this customer had two closed loop lines, one for barrel and one for rack implemented, his wastewater was really going down to the limits, and at the end also his sludge was going down dramatically, so very helpful for him. At the end, his advantage, he has now a very high productivity because we have a high current efficiency. He has no breakdown products in his electrolyte. This electrolyte stays always on new performance, like a new electrolyte is a cyanide, totally cyanide-free process, no cyanide in. And at the end, he can reduce all his wastewater is recycled, and he has no nickel. He can no nickel discharge to the wastewater. That can be also a big advantage. So significant cost savings, and of course we will see also in a moment again this very high amount of CO2 savings. We can tell you a lot, you may believe. Therefore, we said let's also prove that this by a third party, that this system is really allowing the savings, and we did that together with the TÜV in Germany, but it's a global organization. I think you also may know them here. And they confirmed, they investigated, they were at this customer, they checked all these data on their own, they did their evaluations, and they confirmed these savings. And I think despite this savings also in chemistry, what we mentioned before, they also really confirmed the rinse water saving and the wastewater saving. And this was the example for zinc nickel, this CMA closed loop. But at the end, this concept of having auxiliary equipment to improve the process performance, to enhance lifetime, to have more efficiency or stable quality performance, which ensures also being able to deliver in high quality expectations automotive industry. We have a lot of auxiliary equipment available, full portfolio targeting, for example, pre-treatment like Trimax, or also the TriChrome for the passivation. So there is a full portfolio for what kind of applications you may have. And as you can see on the next slide, with this equipment, this additional auxiliary equipment, you can also find for every of your process steps and for every kind of your application possible CO2 savings. And of course, that is always related to your line and need to be evaluated. But I believe there is for every line a lot of potential going stepwise and really analyzing what to save. So please contact our colleagues, contact our team, and together we can really make this turnaround for CO2 and towards an improved environment. With this, let us have a short glimpse also into zinc flakes and zinc flake coatings. As you know, for zinc flakes, one very significant factor is energy, are the energy costs, and we all are suffering that. We know the energy costs in the last years were really doubling, tripling, going up, and therefore, where can we save energy in a zinc flake process? Of course, mainly that will be in baking, if we can reduce baking temperature or, baking temperature and all that would be very helpful. And where can we start in saving energy and approach? Of course, we can think on optimized corrosion requirements, so only use this corrosion performance, what is needed for the application. There we need to work together with the OEMs and the supply chain. We are doing that, of course. On the other hand, of course, if my process and my solution is so stable and so high performing that I can reduce the layer thickness, then I can also save a lot. Curing temperature is one key where I can also reduce CO2. So we will also see that in a minute. And of course, if I can reduce the layers, instead of having 3 or more layers, only having 2 layers or 1+1 layer, why not using this advantage? One system where we could achieve that is Zintec 1 HP. That is a high-performance one-layer system, the base coat. And in this base coat, we can, you see the picture, it is really looking like this. It's a shiny finish, has still very excellent cathodic corrosion protection. And you can already, with this base layer, achieve very nice corrosion performance. If you see that on the next page here, example, after 720 hours, only one layer base coat, still very well performing and fulfilling this test. And this is coming out of a normal industrial size centrifuge, so it's not a lab part. Of course, if you have only one layer base coat and you want to have very high performance system, you should have also high-performing top coat, and this is our Zintec Top XT. And you see here on an example that is a water-based, transparent, inorganic top coat and has a low drying temperature. We are talking here on drying like 15 to 30, 40 minutes at 120 to 180 degrees, so really much lower and really thick. But despite it's very thin, we also will see in the example, it has excellent corrosion performance. We are sharing here just some examples, and to save a little bit of time, I go very fast over, but you can believe really corrosion performance is very good, not only in neutral salt spray test, but as well also as we are seeing in the cyclic performance. What we have seen before, that is for dip spin application, a normal fastener dip spin application, for example. And of course, also for spray applications, you can do a lot in reducing the baking or drying temperatures. and that will always pay into the coating cost reduction, energy consumption cost, and this all, of course, into the CO2 emission. We have developed a new family of products under our X-Link family name, which helps to what can I say, trigger the reaction between polymer and the polymer change at lower temperatures, even at ambient temperatures. On one hand, you can use that with a normal tech dip, which is a kind of our top coats, and here you will see then reduced temperatures, only dried at 80 degrees. So really also with this low temperatures, you can get excellent corrosion performance. And if you are using this X-Link concept also with our usual Syntec 200 XT market-leading product, then of course you can also expect excellent corrosion performance. And even with our Syntec 400, which is organic base and zinc plus aluminium, so also high-performance corrosion protection, you can use this X-Link as additional cross-linker in a 2K system, and then even at ambient temperature, you can get excellent corrosion performance with a ductile coating. So I think this is really something what could be very interesting for applications when thinking on energy saving. An example here, just drying a 44 micron layer at 30 minutes, 80 degrees. So really interesting performance. You see here the result after 1,000 hours. And on the next slide, you will also see how that looks after more than 2,000 hours. So with that, let me come to the end. I think we saw that there is a lot of potential in CO2 saving. You need to look into the details. You need to understand what are the starting points for your evaluations and for CO2 saving. And we would like to start your thinking about that. This should be just an appetizer, what we presented here. And I hope we can come in closer discussion, maybe also during the lunch or later on with the teams also the next weeks to come. And we would like to invite you to start your journey in CO2 saving with your application and your projects.